Number 15. So I want to know if this converges or diverges. This is geometric or exponential. The rate is -5/6. And so the absolute value of that is less than 1. So therefore it converges. Why? And it's the geometric series test. And then the answer would be plug in 1. And there's the first term. And then 1 subtract that. And there's your answer. We could simplify it. We're adding. We could also get common denominators. So that's 11/6. The 6's divide out, and -5/11. Is that number 15? All right, number 16. Uh, 18 take away 12 plus 8, and so on. What's happening here every time, and I think it's easiest to see it with a fraction, that you're multiplying by -2/3. So -2/3, -2/3, that's what's giving you the answers and eventually becomes fractions. So the absolute value of -2/3 is less than 1, therefore it converges. Why? Because of the geometric series test. And then your first term is 18, 1 subtract -2/3. Common denominators, so 3/3, so 3 plus 2, and then multiply times the reciprocal, and you have your answer. What is that? 30, 24, 54/15. Sorry, 3/5. There it is. I get 54/5. Number 17. The limit as n approaches infinity. Use the power terms. They're equally powerful, so it's 2/3. So it diverges. So if the limit is a number other than 1, it automatically diverges. Why? By the nth term test. We're going to learn that if it's 0, it might converge. May not. But absolutely, if it's not 0, it can never converge. If it is 0, it might converge. And we'll go from there. That's going to be question number, was it? 21. We're going to look at it. All right. Here, e to the n factorial. What's happening here? Is this going to simplify down? So here's a good example in terms of what's happening. As you're multiplying, this, and I know you didn't know this, is more powerful. So the factorial is more powerful than the exponential. So as the numbers get bigger and bigger and bigger, if I multiplied it out, you'd see the numerator is going way faster than the denominator. This is going to infinity, so it diverges. And we say it's by the nth term test. So remember that. Boom. All right. How about this one? So I want you to think of this as 4 times 1/3 the n. Then as I plug in 1, plug in 2, plug in 3, what you're multiplying by is 4/3. And if r equals 4/3, then 4/3 is bigger than 1, so this diverges. Oh, sorry, say that again. So you have a 4 in front. So 4 is going to stay the same. It's the denominator. So you're not multiplying by 4, you're multiplying by 1/3. So let me readjust. 1/3. So if you look at it, it's 4/3. The next one's 4/9. The next one's 4/27. That you're multiplying by 1/3 every time. And 1/3 is smaller than 1, so therefore it converges. And then the answer, the first term, which is 4/3, and then 1 minus 1/3. Get common denominators, 3 over 3, so 3 take away 1. And then the 3's divide out, and 4 divided by 2 is 2. Is the first term 4 or 4/3? I made that mistake again, didn't I? If you plug in 0, I plug in 1, and I'm making that assumption, which is a bad assumption. Usually, the bottom of sigma notation, we start with 1, not 0. But you got to be careful. So if I plug in 0, I'm actually starting with 4. So this answer, you would actually add 4 to if I was going to do it that way, or I could readjust it. So I added from here to here, which was 2. I forgot the 4 in front, so just add 4 to it. So this is really the answer, because I got to pay attention. That starts at 0. Let's see if I'll pay attention here. 1. How about this one? So if I go 1 over 4, the next one is 1 over 16, and then 1 over 64. I'm multiplying by 1 over 4 every time. And 1 over 4 is less than 1, so it converges. And then what would the answer be? So this one is starting with 1/4. I feel good about it. And then it's 1 subtract 1/4. So get common denominators, 4 over 4. So 4 take away 1. Divide out the 4's, and you get your answer, and it's 1/3. Yay. All right, 21. So we have a series. Again, it starts at 1. I don't like it when they start at 0 because I make mistakes. And the question is, find the limit as n approaches infinity. And how would I do that? And so the answer is the power terms, that it's more powerful on the bottom. So this is approaching 0. And then B is to explain why the nth term can't be used. So the NTT is only used for divergence. So it's only used for divergence if this limit doesn't equal 0. So if this didn't equal 0, I know it diverges. If it does equal 0, it may converge or it may diverge. Can you see the difference? So this is only used for divergence. If this limit was not 0, then I know it diverges. If it is 0, then I have to think and do some other tools to be able to figure out if it converges or not. 22. All right, these are now review questions. This is called an improper integral. So we're going to write it as a limit as b approaches infinity. You can see the form of it. Oops. Change the infinity to b. There you are. All right. This is going to be integration by parts. So u and du, dv, and then v with the hook, it's going to be negative e to the negative x. And then we write down the limit as b approaches infinity. And then the formula starts with u times v. So it's x times e to the negative x, and it's negative. Subtract. This is going to go from 0 to b. Now it's v du. So when I integrate this, I need a hook that's negative. It's there, so I can undo that. So we have negative x e to the negative x. Subtract. And then just copy. And that's going to go from 0 to b. And then one more step. Keep the limit notation to the very end. So now we're going to plug b in. So we have negative b e to the negative b. Subtract. And then plug in 0. Now 0 times anything is 0. So I'm left with negative e to the 0. So it's helpful to write this in algebra notation so that you can see this is negative b over e to the b minus 1 over e to the b, and then plus 1. So when the bottom is more powerful, this is going to 0, this is going to 0, and that leaves me with 1 for the answer. Make sure I did it right. And I did. Sometimes I do it right. 23. I'm integrating from 0 to 3. Is that right? I like wrote over it. I just want to make sure I wrote it correctly. All right, here, let me try it. Is that 0 to 3? Is that what that is? Yeah. 0 to 3, 1 over x minus 1 dx. All right. So why is this improper? Because x cannot equal positive 1, and that's in between 0 and 3. I think before I used the word middle, I don't want you to be confused by middle. It's in between 0 and 1, so that's why it's improper. So I have to actually set up two integrals because it's in between. So the first one I'm going to use is going to go from 0 to 1. So I'm going to let b, as b approaches 1, from 0 to b. And then the second limit, I'm going to use a, as a approaches 1. And this one's going to go from a to 3. So I'm going to go from 0 to 1 and 1 to 3, split it into 2. And now I'm going to integrate both of them. So we're going to keep the limit notation. The integration of this is a logarithm. And the same integration on the other side, obviously. All right. Now we're going to substitute in. Zero take away 1 is negative 1, and the absolute value of negative 1 is 1. Same thing here. This is going to be, first I was going to plug in 3, right? So 3 take away 1, subtract ln a minus 1. And then look at it. What's the problem? Is that when it approaches 1, it's still undefined. So if I evaluate at 1, 1 take away 1 is 0. And that's where the asymptote is for logarithm. So this is going to go down to negative infinity. So when I plug it in and it's still undefined, it's where an asymptote is, it doesn't converge to an answer at an asymptote. So this diverges because of that. And all I need is one thing that diverges, and then everything can't work then. And then it goes from there. 24. So it says determine the convergence or divergence of the following sequences. Now, sequence is different than a series. So if you take the limit as it goes to infinity of this, if the answer is a number, it does not be 0, then it converges. If it was a series, it's different. But a sequence, so what happens when the bottom is more powerful than the top? This is 0, and then 1 plus 0 is 1, and then it's 1 to infinity, which I think is just going to be 1. Am I missing an n? Oh, well, we're going to do this as a logarithm. Well, there you go. So I'm going to let y equal this. I'm going to treat this as a logarithm because 1 to infinity is indeterminate. It's one of those forms. So if I do treat this as a logarithm, come back. Then I can use the power property. I'm still going to write the limit notation I'll use parentheses. So then that power property, when it's written as a logarithm, can go in front of the logarithm. So the left side is just going to be what it is for now. I'm going to work with the right side. And so I have the logarithm in the numerator, and I'm going to write n to the negative 1 in. So I have a ratio, so then I could see if it's L'Hopital's rule. So n to the negative 1, 1 over n, the left end behavior is going to 0. Here, this is going, 2 over n is going to 0, and ln 1 is 0. This is actually 0 over 0, which is indeterminate, which means I can take the derivative of the top and bottom. So what I see, the derivative of what I see, write it like this if you need to on the side. And so that's going to be negative 2n, negative 2. This is going to be negative n, negative 2. You're going to have to clean this up algebraically. Let me just try to be simple about it. So negative 2 over n squared over 1 plus 2 over n over minus 1 over n squared. I'm just trying to get to the point where I can understand to do the multiply times the reciprocal. So I have negative 2 over n squared over 1 plus 2 over n times negative n squared over 1. If we can simplify this. When I multiply these together, think of this as negative n squared over 1 here. The n squares would actually cross out, because one n squares on top and one n squares on the bottom. A negative times a negative is positive, so you end up with this. Now, as this goes to infinity, this is 0, so it's just 2 over 1. So we have ln y is now equal to 2. So as this approaches infinity, this is 0, and you're left with 2 over 1, which is 2. So write it exponentially, and you have your answer. It's e squared, and it converges. That was heavy lifting. That's a tier 1 plus question for sure. Good job sticking with me with that. 25. So I'm going to write this as it approaches infinity. And see how I'm going to approach this? I want you to notice that n plus 1 factorial is more powerful than just n factorial. So if you simplify this, you can also see it. This is n plus 1, and then n minus 1, and so on. And you can see that that simplifies out, and that this is just a line, and the right-hand behavior goes up forever. So this diverges. It does not converge to an answer. 26. All right, this is some pre-cal work. Write nth term for what you see. So what do I notice? It's going up by 4 every time. So it's linear. That's the slope. And then the first term is 3. And you have it. 27. What am I multiplying by? Or, and understand it. So if I notice it's alternating signs, I'm going to do this. Because then as you put in a positive and a negative, right? That's what's going to happen. And then the bottom is a factorial. 1, 2, 6, 24, 120. If I plug in 1 it's not going to work. It needs to be -1 to the 0. So if I plug in 1, that would work. 1 take away 1 is 0, and then it would match. If I plug in 2, it would match, and so on. 28. 2, 6, 18, 54. What are you doing to get the next term, the next term, and the next term? Is you're multiplying by 3. So it's geometric. The first term, you're multiplying by 3 and to the exponent n minus 1. 29. Determine if the following sequences are monotonic and or bounded. So, first of all, they're monotonic if it's strictly increasing or decreasing. So as I put in 1, 2, 3, 4, 5, 6, 7, 8, 9, go all the way there, it definitely is going in one direction. It's not going to go in two. So as I do it, in fact, it's going to increase. So as I plug in 1, the answer is 3. But if I plug in a half, a third, for whatever, so very beginning, it is monotonic. There's no turning point. It doesn't increase and then decrease. And in this case, when I plug in 1, the answer is 3. And if I plug in infinity, the bottom is more powerful, is going to 0. So that means it's bounded between 3 and 4. It approaches 4, it will never equal 4. 29. 30. Cosine n pi over 2. Well, right away, we know it is not monotonic, because cosine goes up and then down and then up and then down. Monotonic, it only goes up, or it only goes down, or it only increases, or it only decreases. Is it bounded between two numbers? And then cosine is bounded. In this case, it's bounded between -1 and 1. So this answer, the biggest answer will be is, and think of the unit circle, right? Whatever the angles are, it doesn't matter, right? This is just the angle keeps changing. The biggest answer you can possibly get is +1, and the smallest answer you can get is -1, so that means it's bounded. 31. 3 over 2 to the n. This is monotonic. So as you plug in 1, 2, 3, 4, 5, and so on, it is increasing only. It doesn't change direction. But this is not bounded. It's going to infinity. So as you put in larger numbers, the answers get larger and larger and larger. It doesn't converge. So it's not bounded. 32. Find the domain, x and y intercepts, extreme points of inflection, and so on for a trig equation. I'm going to turn the page. This feels like I need more space. So y equals sine x plus cosine x from 0 to 2 pi. So first of all, the x and y intercept. So if I make it equal to 0, I'm finding the x-intercept. And so at what angles are they equal to each other, but one's negative and one's positive? So that answer would be 3 pi over 4 and 7 pi over 4. So they're equal, but one's positive, one's negative, one positive, one negative. So those are my x-intercepts. If I make it equal, if I put in 0 for x, sine 0 is 0, cosine 0 is 1, so we have a y-intercept at 0, 1. Then it says, how about extreme? Take the derivative. So the derivative of sine is cosine, and the derivative of cosine is negative sine, equal to 0. So here are the extreme points. So when they're equal to each other, so that's at pi over 4 and at 5 pi over 4. So we have intercepts and we have extreme points. Now, if I plug in pi over 4 into the derivative, if I plug in, if I do a number line, what am I thinking here, between 0 and 2 pi, for pi over 4, and 5 pi over 4, it's going to go up and down, up and down. So the easiest point actually to pick is right here at pi over 2, because it's an axis. So cosine at pi over 2 is 0. Sine at pi over 2 is positive 1, but this makes it negative. So this value is negative, and now I know they alternate. So this is going to be a maximum, and that's going to be a minimum. What's the next thing? The points of inflection. So now I got to take the derivative again. So the derivative of cosine is negative sine. The derivative of sine is cosine, but it's already negative, so it stays negative. Equal to 0. This is the same situation I had before. So the intercepts are points of inflection. And then sketch it. So pi over 2, pi, 3 pi over 2, 2 pi. All right. And this is going to go up to, what's the greatest value it could be? So the maximum value is at pi over 4. So let's find where that max, what value is the max? So if I go sine pi over 4 plus cosine pi over 4, that's root 2 over 2 plus root 2 over 2. That's 2 root 2 over 2. So that's root 2. So the square root of 2 is a little bigger than 1. But honestly, I'm just going to call it root 2. Why not, right? It is between that. The smallest value is when you plug in 5 pi over 4. So the sine of 5 pi over 4 plus the cosine of 5 pi over 4. So you're going to get the same situation. It's negative, negative, right? So it's negative 2 root 2 over 2, which just equals negative root 2. So that's here at the bottom somewhere. Again, it's smaller than negative 1. I'm happy just doing that. And so the intercepts are at 3 pi over 4 and at 7 pi over 4. So the intercepts are there. The y-intercept is at 0, 1. So that's here somewhere, smaller than root 2. The max is at pi over 4, right there. The minimum is at 5 pi over 4. 2 pi is going to give me the same answer as 0, so it's right there. Same angle in terms of the value. And then point of inflection. So first of all, it's going to be, you can already tell what's going to happen. It's going to be concave down, and then it's concave up, and then it's concave down. And I have the graph. Good work, right? That's a good tier question, but it's not silly. Like to go through the trigonometry and the calculus and put it all together, it's a really good question. That'd be a good question to start again from the beginning and try to do it by yourself and see if you can do it. 33. Take the derivative of this. So cosine y subtract x equals x cubed plus 2. So the derivative of cosine is negative sine. The hook, the derivative of y is y prime, and the derivative of negative x is negative 1. This is 3x squared. The derivative of 2 is 0. To get y prime by itself, divide. And then add 1. And you have it. What number is that? 33. Next, 34. Sometimes I make sure. You know, I check the answer key and make sure that if I didn't do it right, I don't pretend and say, oh, I did it right, and I just move on. So if I made a mistake, I want to know why and go back and think about it with you too. All right. Take the derivative here. So this is the product rule. So the first times the derivative of the second plus the second times the derivative of the first. The derivative of tangent is secant squared. And then the hook is 2y with a y prime. So work your way, be a good rule follower. Next, if it has a y prime, they need to go together. If it doesn't have a y prime, they're on the other side of the equation. So I rearrange it. I subtract 2y. Does that mean subtracting? So I got to divide, right? So I got to bring them together. So instead of this, let's rework this. Because I'm multiplying, these actually go together. So we have 2x y prime subtract all of that. Secant squared y squared, 2y y prime. All of this is one term with a y prime in it, so all of it gets subtracted. The 2y is on the other side. Then I factor out a y prime. Don't be discouraged the way it looks. And then the last step is to divide. And let the algebra, you don't have to simplify anything, let that algebra be what it is. Perfect. 35. Turn the page. The limit as x approaches pi over 2, cosine, x subtract pi over 2. You should first do it by yourself, press pause and try your best. Cosine at pi over 2 is 0, pi over 2 subtract pi over 2 is 0. This is a L'Hopital's rule. Take the derivative on top. That's negative sine x. The derivative on the bottom is 1. Plug in pi over 2 again. Sine of pi over 2 is 1, but that makes it negative 1 over 1, so this answer is negative 1. 36. The limit as x approaches 0 of sine 2x and sine negative 5x. So again, if I plug in 0 and 0, this is L'Hopital's rule. So the derivative of sine is cosine with a hook. This is going to be cosine with a hook. Now, when I plug in 0, the answer is 1. So this is 1 times 2. This is 1 times negative 5, and you have your answer. 37. The limit as x approaches 0, sine 3x over x. All right. So again, if we approach it with 0, sine 0 is 0 over 0, L'Hopital's rule. Take the derivative on top. That's cosine 3x with a hook and 1. When I plug in 0, cosine 0 is 1, and 1 times 3, and the answer is 3. 38. The limit as t approaches 0, 2t, and then secant t. Oops, that's an arrow. So if I plug in 0, I get 0 times 1, and the answer is 0 is what I got. Done. So if you evaluated 0, 2 times 0 is 0. Secant 0 goes with cosine, so it's 1, and then 0 times 1 is 0, and it's over. 39. Use a calculator. Where's my calculator? There it is. To find the area in between those two curves. So we have y equals the absolute value of cosine x plus cosine 2x, and it's from 0 to 2 pi with the x-axis. From 0 to pi, I mean. All right, so let's graph this with our calculator. So if I have something there, which I do, I'm just going to erase it all. So I'm going to press 1 and then delete all and just start fresh with a fresh sheet. Press tab and absolute value, and then type it in 2 cosine x plus cosine 2x, and that's it. Just double check, right? Did I type it in correctly? I think I did. And then we're going to press menu. It's a fun graph. I'm going to press menu, and then I'm going to go analyze. And I just want to integrate because it's with the x-axis. It's not two things bounded, just the integral. That's 7. And then what's the lower bound is 0. And then what's the upper bound is pi. And then there's your answer. So from 0 to 2 pi, yeah, there it is. I just have to press enter. It's right there. And if you can't see it, you can close your hand over it. Oops, what happened? It's moving all over the place. Anyways, let's try it again. So if I go menu, when I press the hand, it moved like the bound. So I'm just going to not mess with it now and use my good eyesight. So the lower bound is 0. The upper bound is pi. And you press enter. And then I see it. It's 4.403. Right? Use my good eyes. 4.403. Can you see it? As soon as I try to mess with moving that number, that's when it was starting to do something to me. But it's 4.403. All right, 40. Use a calculator, again, to find the area of the region in the first quadrant bounded by, now this one has 2 of them, so we're going to press a different button for that. That's 2x, and then y equals 3x. And of course, x equals 0 is the y-axis. All right. So we have to do a couple things here for this one. So first of all, I'm going to get a clean sheet again. Can you see this? All right, so I'm going to go menu, actions, just clear it up. Let's just start from scratch again. And then tab the first one again. Be careful. It's 3 cosine 2x. So 3 cosine 2x. It's good to double check. The second one is going to be 3x only. And then I'm going to like shrink that so it makes it easier to work with a little bit. Whatever. I see that. I need to know where that point, where they cross. So I'm going to press menu. I'm going to go to analyze and then number 4. And then move it to the left and press enter. And then move it to the right. And then it's 0.515. I'm going to use that. 0.515. All right, 0.515. Okay. So I'm integrating from 0 to 0.515. And then top subtract bottom. I'll let my calculator do it, but I can see that the cosine is on top and the line is on the bottom. So if I was going to write down what I'm putting in my calculator, top subtract bottom, that's what I see right there. Now the next thing I'm going to do is press menu, and I'm going to press analyze. Again, it got a little blurry, sorry. See if it comes back. I'm going to press analyze, and now number 8 is 2 of them. So it's going to say, what's the lower bound? It's 0. What's the upper bound? We just found it. It's 0.515. 0.515. Did it say point? There it is, 0.515. And then it gave me the area. And the area is I have it on here too. Yeah, 0.888. Do you see that there? 0.888. Done. Nice to have a good calculator, right? But you have to know how to use it, right? Having an amazing car but not knowing how to drive it. Sad, right? 41. Last part all have to do with the same question. So set up integral, find the volumes of some described. So the solid is formed by revolving. So just set it up. Question number 40. So remember when we did top subtract bottom around the x-axis. So what I'm going to do is just do a little sketch. Just to get a sense of what I'm doing. So there's my little sketch where it's top subtract bottom. In question number 41, it says revolving it about the x-axis. So there's a gap there. So how many circles do we have? Or 2. the big radius, the small radius, all of this is going to go 0 to 0.515. The big radius goes from the top down to 0. So it's the top curve, subtract 0, or just 3 cosine 2x. The small radius is the line, subtract 0, or just the line. And there's the setup. 42. Again, we're revolving it, but this time around y equals 4, which is above here. Again, it's 2 circles. The bounds stay the same. So I'm going to set it up. We have a big radius and a small radius. So for y equals 4, you go the bottom to the top, or tops, I'm sorry, to subtract bottom. So that's 4 subtract the line. And then the smaller radius will be 4 subtract the curve. Number 43, I don't want to run out of space here. 43, the solid is formed by revolving it about the line x equals -1. So that's here. This is going to be a shell. In terms of what's happening. So shell is 2 pi. And then it's the radius times the height. So it's still this. The radius is right subtract left. So because it's to the left, we have to go x subtract -1, or x plus 1 if you like. So again, it's x subtract -1, or x plus 1. That's what the radius is. The height is top subtract bottom, which we said was cosine 3x subtract the line, right? 3 cosine 2x subtract the line. So the cosine, subtract that, is top subtract bottom, which is the height. Done. Last one, 44. The solid is formed by using rectangular cross sections. No pi, it's a rectangle. Base times height. So the base is that, which is top subtract bottom, times, are always half the bases. Now I'm going to tell you that. We could write it again, or we could square it and divide by 2. Same thing. Or you could write it like this and write it twice. But isn't it fancy to do it the other way? So I could have went times 1/2 on this, or if you multiply it twice, it's squared and then divided by 2. Fancy, right? All right, Mr. G Math, I'm really proud of you for doing your work. Until next time.